All right. Good morning. Good morning from my end. So this week is um second to the last week for the second month. So according to our schedule, this week we're to look at Matplotlib. Or rather, this week generally it was supposed to be data visualization, right? So we are going to look at Matplotlib today. Matplotlib. So when it comes to data visualization, we cannot finish discussing about data visualization in with Python without calling Matplotlib. So that's why we have this training today. So the first thing is, well, let's try to understand what Matplotlib is, right? So Matplotlib is a popular Python library for data visualization, just like I said. So is actually a very popular data visualization tool. And as a matter of fact, it is the foundation for which other visualizing tools are built upon. So it allows users to create a wide variety of what static, animated, and interactive plots. So Matplotlib allows us to do what? To create static visualizations. That's when you talk of PNGs, JPEG that are static, not moving, right? We can use Matplotlib to generate um such plots. And we can also generate animated plot. So something that looks a bit dynamic, right? It can be Matplotlib can be used to actualize that code and as well interactive plots. So for interactive plots, these are plots that describe, right, in details what the visualization represents. So having enumerated all of this, we can say that Matplotlib is a plotting library, right? For Python programming language and its mathematical extension, which is what? NumPy. So it provides what? An object-oriented API for embedding plots in application using general purpose GUI, graphics user interface. So before a plot can be made with Matplotlib, we understand that what there is an API that helps that plot to be what made possible. So that API, another toolkit, just like the GUI toolkit as a graphics user interface toolkit. Example of such are Thinkers and each other one. Uh, Wix Python, WX Python. So that's when you're going fully into UI UX. That's when you have more of that. So it is widely used in data analysis. So Matplotlib is widely used in data analysis and also in machine learning. So why do we use all of this? Number one is for what? Is for visualizing trends. We want to see how the trend looks like. And as well, relationships. So let's see how a variable is related to this other variable. And as what's distributions of data. So I want to see which particular region do we have more of our data. So when it comes to distribution of data, we can have something like the normal distribution, and which is also the Gaussian distribution. All right, so no, without much talking, let's proceed to the game. Mind you, we already said it was an external library. So once a package is a library, you have to always do what? Import that library. So importing necessary what? Libraries. You know, when I was redefining Matplotlib, I said what? That it is a plotting library for Python programming language and its numerical mathematics extension, which is what? NumPy. So for me to be able to use Matplot very well, I need to also have a knowledge of what? NumPy, numerical Python. So that's why I did what? Import NumPy as NP. Then import matplotlib.pyplot as what? PLT. So we run this guy, right? Now, after having run that, we now do what? Try to get the basic plots that are required. So one thing about plots is that when generating plots or when visualizing your data, you don't just limit yourself to what has been taught, right? That's why we said the reason for visualization is to do what? To see the trends. The trends. So if you have like a time series data, you want to see the trend, how a variable changes with respect to time, right? And then we also talked about relationship. So how variable A relates to variable B. If I increase or if there's an increment in variable B, will it affect variable A directly or inversely. So that's relationship. Is it linear? Is it non-linear? Is what we are looking out for. And the same thing is applicable for what? Distributions of data. So we can have a data ranging from 0 to 100. We can have a variable or values of a particular variable ranging from what? 0 to 100. And then at some point, I have about 70% of my variable, of the values of that variable within the space of 75 to 100. So we'll now know what kind of distribution is that. Is it a right skewed? Is it left skewed? Or is it a normal distribution? So those are the things we need to know. So for us to understand this basic visuals, the first three types of plots we need to know are what? The line plots, right? The line plots can be used to analyze trends. So it goes in form of a sinusoidal graph, right? It can be used to represent trends. And the same thing is applicable. The next one is the bar plot. So for the bar plot, we can use the bar plot to do what? To understand the distribution of our data. Is it a Gaussian, the kind of distribution that we're having, the mean, median, and mode at the same place, possibly at the center of our data distribution. And then the scatter plot can be used to do what? To evaluate or to understudy the relationships that happen between two or more variables. Two or more what? Variable. So let's begin to analyze all of this. Starting with a line plot, we said that a line plot is useful for showing trends over time or a continuous data. So when the data is continuous, we can as well do what? Use a line plot to represent or to visualize them. It connects data points with a continuous line, making it ideal for time series data. Remember I mentioned something about time series data or mathematical functions. So for time series data, that means those data that are bound to time should be visualized using line plots. So you see the trend as the time changes. What is the change that is experienced from the available parameters. And the same thing is also for what? Mathematical functions. So these mathematical functions could be f of x being equal to sine x and all of that. So all of this can be visualized using what? Line plot. So let's look at a quick example. We are generating a random number bit from what? 0 to 100, right? 0 to 0 to 10, sorry. 0 to 10, and then there are about 100 data points. So let's compute the sine function of x. Let's compute the sine function of x. Mind you, the x we are considering here is with respect to the numbers we've generated from 0 to 10 that are in 100 points. And then having done that, here is where we have the sine function. So remember we said we can as well plot what? Mathematical functions. So we said np dot sine x. So what that np there is our numpy. So we cannot say plt dot sine x. No, plt, which is Matplotlib, does not have the mathematical operations or functions for a sine of a particular value. So, and then how do we now continue? The next thing is to set the size, the figure size. Setting the figure size, PLT, which is Matplotlib. Remember the AKA name was what? PLT dot figure. This figure is telling you the size of the figure, right? And then you said, okay, that figure we're looking at, I need the size to be this, right? The size to be dimensioned 8 by 5. So the dimension of the horizontal comes first before the vertical. So the horizontal will be having what? 8 pixels, and then the vertical will be having 5. So sets the figure size. Why do we set the figure size? One, to make our plots look legible. Two, to make our plot beautiful. And then three, to make the plot readable. So you can read the plot even from afar, even when I'm not with my glasses, I can still read the plot. And then the next thing is to do what? The plot, the sine wave. So it should be the sine function as well, the sine function. So how do we do that? PLT, remember we're still dealing on what? Line plot. So PLT dot plot, open brackets, XY. XY. So we are plotting Y versus X, right? So one Y on the Y axis, which is on the vertical axis, and X on the horizontal axis. So for us to achieve that, when we have our PLT, when we have our what? PLT dot plot, the first variable that comes is what? The horizontal value, which is X. And then the vertical variable will come next. And the label sine wave. So the label is for the legend, and the color, which is B represents what? Blue. So the color B represents blue. Let's forge ahead. So that's for what? Plotting the sine wave. Then we can as well do, we will now do what? Set the labels, the labels on the Y and X axis. So BLT.X label, what should be on the X label? X.X dash axis, and on the Y label, Y dot axis. So lines plot example becomes our what? The title. So the title of the plot is what? PLT.title line plot example. Then PLT.legend is what we enable our label here to show, right? This is what we are looking out to display the legend. And then PLT.grid, this boxes or cells that are inside of our plot is being displayed by this guy, PLT.grid. Then PLT.show render the plot. It brings out the plot. Even though when you don't put it, it will still output a plot, but then it looks better you plotting it. So when you run this is what is expected to be displayed, right? So then this is a good example of what a line plot. So the second one is a bar plot. A bar plot is useful for categorical data visualization. It represents data in regular bars. So the data here are represented in bars, making it ideal for comparing quantities of different categories. So you can compare quantities of different categories. Let's say, for instance, we have in a particular class the ratio of boys to girls, right? So with the help of a box plot, we can clearly see that, okay, let's say that the girls are what 50% less than the guys in that class. So how were we able to pinpoint, or how were we able to by virtue of inspection say that it's because of what the bar plot we have done was produced or generated. So categories equal to what this guy, we have the categories, right? Which is A, B, C, and D. So these categories can usually not be a numerical values, right? They can be strings, and the side will be alphabets, right? And words, depending on what is required. And then those are the values assigned to each of those categories. So for A, we have 5. For B, we have 7. For C, we have 3. And for D, we have what? 8. So these values corresponds to each category for this particular example here. So I'll say that A is equal to what? 5. B is equal to 7. C is equal to 3. And D is equal to what? 8. With that, I have been able to do what? Assign these values to those categories. Then this is how we've talked about how to set our figure size already. So we need not discuss that for want of time. Then plt.bar, here is where we are creating the bar plot itself. Plt.bar, open brackets, categories, right? Remember, what is to be on the horizontal comes first. So categories is what we are expecting to see on the horizontal, and then the values, the values, right? And then WhatsApp, and then color. So this color is to distinguish the categories one from another. So PLT dot X label this. So, and all of that are what we discussed. So when you run this, you should be expecting a plot like this, that A is having what? A value of 5, B is having a value of 7, C is having a value of 3, and then D is having a value of what? 8. So that's for the bar plot. So the next is the scatter plot. So a scatter plot is useful for visualizing the relationship between two numerical variables. So look at this very closely. For a bar plot, we can do what? We only do what? We see the relationship between a categorical variable and what? A numerical variable. But when you want to see the relationship between two numerical variables, what you make use of is a scatter plot. So it displays data points individually, helping to identify correlations or clusters. So it helps to identify what? Correlations or clusters. So how do we go about that? Let's generate a random variable for our variable x, and then let's generate another random variable. There are 50 random variables for what? Value y, right? And then we set our value size, sorry, figure size. We set our figure size. So plt.scatter. Mind you, when we're doing line plots, we did just plt.plot. When we're doing bar plot, we did plt.bar. And then it comes to scatter plots now, we are having what? Plt.scatter, then open a bracket x, which is what should be on the horizontal first, and comma y, comma color. What color do we need to how do we call it now? To represent the data points, and then the alpha. How do we want this points to be? Edge color should be what? Black. So after the magnet magenta rather, after the magenta color, the edges of that magenta color should be what? Black. That is what I just did here. So this guy, this particular line of code creates the scatter plot we've been hoping to get. And then this accounts for the X label, this accounts for the Y label, and then this guy accounts for the title that is being referred to as what? Scatter plot example. And then we showcase our grid lines. So the grid lines are usually for easy tracing of what the values, so you don't spend the whole time there. And then the last one is what you show what you're what's plotting. So that's is that you do this now, you see we have those plots here. So we can customize our plots by doing what? Adding labels, titles, legends, and annotations. Also, customizations can help in making what? The plot look more informative and readable, right? Labels describes axis, and then titles gives an overview of the of the plot, and then legend explains the different lines or bars, and the annotations highlight the key points. So let's take a good example. I did a line, a visual, I did a plot of sine and cosine waves. So I have them here, sine and cosine wave generated y1 and y2, and then I made a plot of x against y1, x against y2, right? And then so let's try to see the X label stands for what? Time, and the Y label stands for what? Amplitude. Then the title is what? Sine and cosine waves. So plt.legend, plt.grid. Remember, those guys are always there to help purify our plot. And then so let's add some form of annotations. Annotation mark point X, Y. So this guy is you calculate depending on your plot to know where you put your annotations. And then the last is this guy, plt.show. So if I should run this, you're going to have this guy. So you looked at this plot is looking more informative and more interesting. So this ends the training for our introduction to Matplotlib. Tomorrow we'll look at advanced visualizations. But before then, I would love to see how you print some of those guys inside any plots of your choice. So you can create a plot of y equals to x2, right? For values of x that ranges from -10 to 10, right? And then create a bar plot of a bar plot a bar chart showing sale data for 5 products. So you can decide any data of your choice or any product of your choice. And then you create a scatter plot with random points and customize its appearance. So those are the assignments or the exercise you get yourself engaged with before our next video that should be coming up tomorrow. So before then, until tomorrow, do have a beautiful day.